Hi everybody! Today we will show you some high dynamic range measurements on two modern spectrum analyzers. The first unit used in our test is the Russian flagship spectrum analyzer SK4 Belon 240M, manufactured and designed by Elvira company. The second one is Agilent PSA E4440A, which has been the default industry standard for the recent decade and which is by and large one of the best spectrum analyzers ever made. We will use a microwave signal source HP70428A to provide a low phase noise reference signal to both units. Those who are familiar with low phase noise measurements will probably remember that it is an older equivalent of the modern N5508A signal source used in Agilent E5505A phase noise measurement system. One more signal source used in our measurements will be a two-channel synthesizer Belson 200 manufactured by Elvira. This synthesizer incorporates two quicksync modules designed by Phase Matrix company, along with step attenuators and power amplifiers provided by Elvira in a benchtop format. This is an extremely good unit for any kind of two-tone dynamic range testing tasks, since its architecture built around quicksync synthesizers provides very low phase noise across the entire frequency range up to 20 GHz, and it provides two signals with an inherently good isolation which do not modulate each other, and this is an extremely important feature for any type of intermodulation distortion measurements. So, the first measurement we are going to show is a single tone dynamic range measurement. For this measurement we will apply a spectrally pure 10.2 GHz signal from the HP70428A source through a power splitter to both analyzers. This test signal has a known phase noise value of lower than -130 dBc/Hz at 10 kHz offset. This should be low enough to reveal the phase noise of both analyzers in question, or in other words, their maximum single tone dynamic range. As we can see, Agilent PSA shows a dynamic range of 90 dB in a 100 kHz span with a resolution bandwidth of 100 Hz. This corresponds to roughly -110 dBc/Hz phase noise, which is consistent with its specification. Now we should tune to the same signal with SK4 Belon 240M using its touchscreen functions and front panel buttons. Remember, this is the same signal, 10.2 GHz, fed to both units simultaneously through a power splitter. We are gradually decreasing the span until we reach the same value of 100 kHz with the same resolution bandwidth of 100 Hz to perform the comparison under equal conditions. What we see here is a single tone dynamic range in excess of 100 dB, which is quite a solid figure for a 10 GHz carrier. This figure reflects a 10 dB difference in the inherent phase noise level between the two spectrum analyzers. The phase noise of Belon 240M is roughly the same as an Agilent PXA and is definitely better than an Agilent PSA. Belon 240M has a nice scaling feature. It can not only increase the number of decibels per division, but it allows for the number of divisions to be increased, up to 14 divisions per the analyzer screen, which is sometimes more convenient for observing and estimating signals with a truly high dynamic range. Narrowing the resolution bandwidth down to 10 Hz provides us 10 dB more of dynamic range, exactly as one would expect, given a total of 110 dB. The two spurs present on the input signal with a level of -100 dBc each can be easily identified now. Agilent PSA allows increasing the number of decibels per division only, which sometimes complicates figuring out how much dynamic range one has available. In our example, we set the vertical scale to 130 dB, the same value as in the case with SK4 Belon 240M. Using delta marker, we will determine how much dynamic range PSA can offer from the signal peak to the noise level with the given resolution bandwidth settings. Okay, it is a value of roughly 95 dB. As you can see, for the same settings, Bell 240M provides 108 dB of dynamic range. It should be mentioned here that the results of both units are quite respectable. The difference, shown here, emphasizes the importance of the analyzer close-in phase noise for this type of high dynamic range single-tone measurements.